In lesson 2.7, we're going to look at graphing inequalities. Some rules that we need to review for graphing inequalities. First of all, and some are going to be linear inequalities, we're also going to look at absolute value inequalities. But the boundary line rules, or boundary line when it's linear, or boundary rules, you need to use dashed lines sometimes, solid lines sometimes. So these are the rules, and you need to get these in your notes. If it's just a less than or a greater than symbol, no equal to under the symbol, it's a dash line. If it's less than or equal to, or greater than or equal to, it's a solid boundary line. And then the shading rules, which you also need to write down. I know some teachers, when they teach it, try a test point. I don't usually do that. You need to get things solved for y. If it's y is greater than something in terms of x, whether it's linear or absolute value, in other words, the y side is greater or greater than or equal to, we shade above the boundary. If it's the opposite, if it's less than, so the y is less than the other side, we shade below the boundary. So you need to get those things down, and you need to know those. Those will not be given to you. So study those, make sure you know them. First one we're going to look at is linear inequalities, and this is a little bit of review. You've done this in the past. You need to get in slope-intercept form first. So we want it in y equals mx plus b form. And it's not really y equals anymore. It's going to be the inequality symbol, but you solve an inequality just like you solve an equation. So we want it in mx plus b form. So we want to get y alone. So if we look here, we have x minus 2y is less than 4. First thing to do is to get rid of x, so we're going to subtract x from each side. So I have negative 2y is less than, instead of writing 4 minus x on that side, we're going to write negative x plus 4. Now we want to undo, over here on the left we've got multiplying y by negative 2. We need to undo that. So we divide by negative 2. We take each term here and divide by negative 2. Don't forget, when you divide or multiply by a negative, what do we need to do? Switch the sign, the direction of switch. I'll just put the sign here, meaning the inequality sign. Do not forget this. If we would have divided by positive 2 here, we wouldn't switch it. So I need to switch the direction of it because I divided by a negative 2. This is a negative 1 divided by a negative 2. Negative divided by negative is positive. We're going to write it as 1/2 x. Here I have a positive 4 divided by a negative 2, which is a negative 2. So there's my inequality. Solve for y. Now, you graph the boundary line. So my y-intercept, this is linear now. So the y-intercept is negative 2. My slope is 1/2. So I'm going to go rise 1 and run 2. So up 1, right 2 from my y-intercept. So y-intercept is negative 2. I'm going to rise 1. So up 1, right 2 would be over here. And I'm going to repeat this a few times. So I'm going to go up 1, right 2. If I went the opposite way, I'd go down 1, left 2. Down 1, left 2. Now, let's take a look at our boundary. Does it need to be solid or dashed? There is no equal to part. If you look right here, there's no equal to part on it. So we are using a dashed boundary line. So make sure you draw it dashed. And I'm going to pull up my line here. And I'm going to do a dashed line. So I'll grab this line. My boundary is dashed. So dashed boundary line. Now, do I shade above? So we want to do, let's write these things down. We do a dashed boundary line because of this symbol. And we want to shade, notice, this is of the form y is greater than something. So y is greater than something means I shade above. So I'm going to shade above this line. So it's all these points above that line, but not including the points on it because it's dashed. So in other words, all those points, if you picked any point in that shading, if you plugged them into the original inequality, they would make it true. All the points on the non-shaded side would not make it true. That's what it really means when we're talking about inequalities. Here's a word problem. The SAT has two parts. One tutoring company advertises that it specializes in helping students who has a combined score on the SAT that is 900 or less. Write an inequality to describe the combined score of students who are prospective tutoring clients. Then we're going to graph the inequality, and then we're going to answer that question about it. So, writing the inequality. We've got math score, verbal score, and then the combination of the two. So for part A, to write the inequality, we're going to let X stand for math, because math is down here, so that's X, verbal is Y. So the combination of the two scores would be X plus Y. Okay, so if X is math score, Y is verbal score. And notice it says 900 or less, so when we combine, add our math and our verbal score, they're going to help people that are less than or equal to 900. There's our inequality. Now we want to solve for Y. So if I do that, I subtract X. So Y is less than or equal to, I'm going to write negative X plus 900. Which means if I graph that, my slope is negative 1 over 1. My y-intercept, my b, is 900. So you're going to have to approximate where 900 is. There's 750. So 900 is going to be somewhere up here in that general area. Now, because we're not going by ones, down one, right one, we can't just go on this grid because it's not going by ones. But if you think about it, down one, right one, okay, think of it with this. We're going down the same amount as we go to the right. So what I'm going to do is I'm going to get a point that's on the x-axis. So I'm going to go down 900 to the right 900. That's the key thing, that we want those to be the same. So if I go down 900, I get to the x-axis, and then right 900 is going to be right over here. Because if I went down one, right one for each one, that means the units have to be the same. This is a solid boundary line because of this symbol. And we're going to shade below because its y is less than or equal to something. So it's a solid boundary line. So let me grab my line. And we're going to grab solid. I'll do blue. We're going to go from here down to here. Solid boundary line. And then we're going to shade. And you notice this is a real life situation problem, so we're only doing positive first quadrant values where both scores are positive. So there's what we're talking about. So there's B, graphing the inequality. Part C, does a student with a verbal score of 480, so that means that's Y, so Y is 480, and a math score of 410, so that's X, remember X is math, so 410. So a couple different ways you can look at this. If you look at the point 410, 410, 480, is that point in the region? So if I went to 410, it's going to be somewhere in here, and then up to 480 would be short of 500. Can you see that, yes, it's going to be in that region? That would be the general area. It's below the line. It's in the shaded region. The other way you could do it, you have X plus Y is less than or equal to 900. If you actually add those two scores together, so it would be 410 plus 480. Is that less than or equal to 900? Well, that's 890. And it is less than or equal to 900. So, yes, they qualify for the tutoring company's guidelines. Okay, absolute value inequalities. This is new, okay? And you haven't done these before. You've done linear inequalities. Remember absolute value, which we just talked about in the last lesson. Absolute value graphs. What shape do they have? They are V-shaped. So I know when I draw my boundary, if it's got absolute value in it, which this does, it's going to be a V-shaped boundary. We don't really call it a boundary line because it's not a linear function. What you need to do is, just like when you were graphing absolute value equalities or equations, is you need to make a table. We need to pick some values to get our V shape. So let's pick some values. Let's start at -2. If I plug -2 in, I have -2 minus 2. Absolute value, well, that's a -4 in there. The absolute value of -4 would be 4. If I plug -1 in, -1 minus 2, which is -3. Absolute value of -3 is 3. If I plug 0 in, 0 minus 2 inside absolute value would be absolute value of -2. Absolute value of -2 is 2. If I plug 1 in, I do absolute value of 1 minus 2. That's -1. Absolute value is 1. Notice I haven't gotten back to where it's V'd yet. I've got -2, 4, -1, 3, 0, 2, 1, 1. Okay, so I got to keep going here. 2. If I plug 2 in, 2 minus 2 is 0. Absolute value of 0 is 0. Still haven't gotten to where it's V'd because this is not linear. It's got absolute value in it. I go to 3. Plug 3 in. 3 minus 2 inside absolute value is 1. Absolute value of 1 is 1. Right here, when you start to see those repeat value, this is where the V starts. So 3 comma 1, it starts to V back up. If you put 4 in, 4 minus 2 is 2. The absolute value of 2 is 2. So 4, 2. You can see 5 is going to be 3. Now, you got to look at your symbols here. The boundary, before you start drawing it solid, you got to make sure it's solid. If it's this symbol, that does mean a solid boundary. And we don't call it a boundary line here because it's a V shape. So it's a solid boundary. If that would have just not had the equal to part on it, we would have done a dashed V. So it's a solid boundary or a solid V. So we'll go ahead and make the solid V. I'm just going to draw this one in. So solid V. Now, because it's an inequality, right here, we have to use our shading rules. Its y is greater than or equal to something. Okay, it's got absolute value in it. That doesn't matter. The y side is bigger. That means I shade above the V. So I shade above the V, which would be all my points up here. If that would have been less than or equal to, then I would have shaded all the points below the V. So the shading rules still apply, it's just it's not linear anymore.